Let's see what we got here. I think this is a median that I had previously done. Looks pretty short. Maximum level sum of a binary tree. Given the root of a binary tree and the level of its root is 1, the level of its children is 2, and so on. Return the smallest level x such that the sum of all values of nodes at level x is maximal. The smallest level. So I think this means find the sum of the nodes at the same level that adds up to the sum maximum. And if there's a tie, return the smaller level. So here 1, 7, and 1, so it'd be level 2 for the 7, 0. Number of nodes in tree is 1 to 10 to the 4th. Okay, so this was a breadth first search. And for breadth first search, you either use a deck or a alternating set of alternating arrays for the level nodes. So I think I'll probably use an alternating array. So I think this should be something like the current array of nodes is just going to be the root. And then I'll say the current sum is going to be current sum should be what? Maybe negative infinity. I'll store the max sum as, actually current sum should probably be 0. Max sum should be negative infinity. And then I'll iterate through, I think it should be something like while current. And then I'll have the next level of nodes. It's going to be empty array. And I'll iterate through all the nodes of the current level, add them to the current sum, and then add their children to the next level array of nodes. I guess current sum should probably be initialized here. Initialized and reset here. So for every node in the current level, current sum plus equals whatever this node's value is. And then the next level adds whatever children this node has. So node.left, node.right. So I guess here if it has a left, append that to the next level array of nodes. And if it has a right, append that to the next level array of nodes. And then after the loop, the current level becomes the next level. And if the current sum is greater than the maximum sum stored, maximum sum is going to be equal to the current sum. I guess I need to do max level as well. I guess this should just be answer. Answer is equal to whatever level this is. I need to actually keep track of what level it is. I guess this should be level equals, do level equals 0 there and level plus equals 1 here. Maximum, I think that might be it. So we set the root as the initial level nodes while there is something set the current sum to 0, set the level to increment, have an empty array of the next node's level, or the nodes of the next level, every node in the current, add that to the current sum. If there is a left, add it to the next level. Okay, I think that might be it. Do. Huh. Not particularly fast, is it? Do. Wonder if this would be. Do. Wonder if I can somehow not have an if statement here. Also do also do a deck, double-ended queue. Do. It's there. Interesting. Wonder if this is the node. Current sum. I'm honestly not sure how this. I say this a lot. I'm not sure how this is improved. It doesn't seem very somehow collapsible. While current. I mean, I guess I could do a deck just to see. So the deck version of this would be something like answer equals 1, level equals 1. I guess it'd be something like while what would be while true. I think you need to size is equal to 1, a deck is equal to, sorry, a deck is equal to a double-ended queue starting with just a node, and then it would be something like for for I in range of the size. I guess I need to have a count of the next size. Do I? Maybe not, actually. For I in range size, you take the node from the top of the deck, and you you do everything, you process it. So current sum equals 0, current sum plus equals the node value. If the node has left, deck appends that. If the node has a right, deck appends that. And afterwards, after you're done processing through everything in the front, size becomes, so size is the number of nodes at the current level of the tree, which is now going to be everything that's currently in the queue. So length of deck. Guess you probably want to increment the level here at some point. And if the current sum is greater than the maximum sum, current sum equals maximum sum, or maximum sum equals current sum. And answer equals whatever level this is. I think that might be it. Probably forgetting something. Node. Oops, this should be root. Yeah, I need to initialize this. So say answer equals level equals size equals 1. And max sum is initially -infinity. Oh boy, it's to infinite. To infinity and beyond, while true. Oh, yeah, I can tell why it's while true here. I think it should be while size is greater than 0, maybe? While size. At some point, the next level of nodes is going to be empty. Or the size is going to be 0 here. So yeah. See how fast that goes. It's the same thing. How odd. There's some other traversal of this tree that I don't know about. Given the root, maximum level sum. You have to traverse everything, I think. I wonder if there's a way to do some sort of recursive thing. I wonder. Oh well, I think, I don't know. Either of these is fine. I guess I'll just keep the last thing. I don't know how to speed it up. Excuse me. Okay. So summary here, this is just a problem above solution is typical breadth first search. Traversal of a tree using a double-ended queue. Alternatively, could use two array of nodes for current level and next level, alternating. So for breadth first search deck, keep a count of the number of nodes in the current level and process exactly that many nodes from the front of the queue. When processing a node, add its value to the running sum for values of that level and its children nodes to the queue. After processing the nodes, compare sum to stored value, update the size of the number of nodes at the level. At that level appropriately. Alright, so yeah, just you have your default size, it's just 1. Your deck has your default starting node, which is your root, and then process exactly that many nodes from the top of the queue. Each one will add its children to the queue and add its value to the current sum, which starts obviously at 0 for the level. Compare to some maximum, update the maximum, update the level, answer level as necessary, update the size, and then if this thing loops. Time complexity is going to be O of n, where n is the number of nodes in the tree. The loop will iterate over every node once. And then space complexity, this should be O of 1. I guess there should be O of n, worst case, since it could be a kind of 2-level tree. Like maybe you have your root node and your next level is 1,000 children. Actually, it only has left and right, huh? Yeah, then I guess in worst case be like O of n divided by 2, something like that. Which is still O of n. I guess in the worst case, since it could be a full tree where the bottommost node, bottommost level has n divided by 2 nodes, which will at some point be within the queue.